Does everybody have this note sheet from last class? Does anybody need an extra copy? Anybody needs an extra copy of this? If you don't have naming ionic compound notes, let me know. Do you all have a periodic table in front of you?
No.
You should take out your periodic table and use it. Okay, so I'll give you an extra packet. All right? Sure. Okay. So, what are ionic compounds between metals and non-metals? So, if you have a periodic table, we know that this side of the periodic table is metals. Is that right? This side of the periodic table is non-metals. So, if an element from this side, that is metals, combines with an element that's in the non-metal side, then it's an ionic compound. All ionic compounds will always start with a metal. They'll never ever start with a non-metal, except in a very few cases. Now, every time, so this is a metal. K is a metal, calcium is a metal. All right? So when it is a metal, all you do is you go to the periodic table and look up the name of that metal. It will say it's potassium and calcium on the periodic table. Are we good? And then the metal is generally attached to a non-metal. Is that right? For that non-metal, the ending changes to what? It changes to an ide. So nitrogen will become nitride, phosphorus will become phosphide, selenium, selenide, oxygen oxide, sulfur sulfide, bromine bromide, fluorine fluoride, chlorine chloride, iodine iodide. Are we good? So now I'm going to name the first compound. This is potassium off the periodic table. Is that right? And what will the sulfur become? Sulfide. So the name of this compound with this formula is potassium sulfide. Is there a student who would like to volunteer and name the second compound? Yes, Daniel.
Sodium chloride.
Sodium chloride. Sodium, as is from the periodic table, and the chlorine becomes chloride. Can we look at the third element? Anybody wants to volunteer and name the third element? Yes, Matt.
Strontium nitride.
Strontium nitride. Strontium nitride. Are we good? Who would like to volunteer and answer the next one? Yes, Toad.
Sodium oxide.
Sodium oxide. Can we, Morgan, can you help me with the next one? BeF2. Be atomic number is 4. Beryllium. Fluoride. Very good. Beryllium fluoride. What about the next one? Who volunteers? Not Daniel again. I need somebody else. Yes. Rubidium. Rubidium phosphide. Can I have another student volunteer? Gretchen. Beryllium chloride. Beryllium chloride. Can I have another student volunteer and do the last one? Christina?
Magnesium nitride.
Magnesium nitride. Is everybody good with labeling or naming these type of compounds? Now, can I have a student read this paragraph aloud. Who's going to read this aloud? I need a student volunteer. Morgan?
Notice the number of items required by the name. The reason for the numbers is to balance the charges. We know that for the main block, the SCP block elements, their ions will do the same charge nearly every time. These charges are also called oxidation states. Label the chart below with known oxidation states.
Can I have a student help label the oxidation state or the charges for the S and the P block elements? Anybody who has not done it before? I need a student to volunteer who didn't answer naming before, not the warm-up. Anybody who didn't answer a naming question? So what is the oxidation state or the charge here? Yes, Audrey, what is it? It is +1. What is the next one? +2. What is this one? +3. Now we are going over to the negative side. That will be -3, -2, -1, and 0. Is that right? So these never ever change for the S and the P block elements. What is it that we haven't done so far? We haven't done the transition metals. So let's go over to the next side. All right? So I need a student to read this paragraph. Not, yes, Evan. Sorry, Justin. Yes. Main block means which block? Main block means S and P. All right, go ahead, Justin.
To name compounds formed between these main block elements, you simply need to name the cat ion and the anion with an IE that ends in. As they will form the same compound every time. Sodium will always have a +1 charge, and fluoride will always have a -1 charge. Therefore, sodium fluoride will always be an ion.
Go on. I need a student to read this paragraph. So we're now into transition metals. Yes, Gretchen.
The charges of transition metals can vary due to electrons in the D block. All metals in the D block except for 5 plus 10 and lead have multiple possible oxidation states.
Okay. So let's do, okay. I need another student to read this paragraph also. Let me see if they process this. Yes, Tony.
Because the charge of these metals can vary, we need to add something to their chemical name so we can identify the particular charge the metal has. For example, if iron with a +2 charge was to bond with chlorine, -1 charge, it would form FeCl2. But if iron had +3 charge, it would form FeCl3. Therefore, we cannot name either of these compounds iron chloride, as they are different compounds with different number of chlorines. We will add a Roman numeral to each name to differentiate between them. Iron with a +2 charge will be called iron 2, and iron with a +3 charge will be called iron 3.
So here are the rules for determining the name of a transition metal compound. Can somebody volunteer to read that aloud? Can somebody volunteer to read that aloud? Who volunteers? Yes, Evan.
Write the name of the metal ion of the ion it's bonded to, ID. Number 2, find out the total negative charge of all ions it's bonded to. Number 3, divide that total charge up between how many metal ions are there. Number 4, turn that number into a Roman numeral. Number 5, put that Roman numeral in parentheses after the name of the metal ion.
Okay. So the video that I asked you to go watch was about naming ionic compounds with a transition metal. So ion can be a +2 or a +3. Is that right? Now, there are two different ways of doing it. This way of doing it is the way I'm teaching you. Is that right? I'll also teach you the way the video is teaching you, how to name compounds. All right? Remember, the idea is to balance the charges. Are you with me? Now, this is the formula given to me, FeO. Is that right? So now, I'm going to write iron, step number 1. Write the name of the metal ion, and the ion it's bonded to with an ide. I'm going to leave some space in between, and what will oxygen become? Oxide. So I've written iron oxide. Now I need to write a Roman numeral. Does everybody know Roman numerals? Do you know what stands for what? Let's, in the bottom of that page, write Roman numerals. And let's do this for students who may not know what Roman numerals are. All right? So if I just put an I, what does that stand for? 1. All right? If I put 2, then that is a 2. This is a 3. 1 followed by a V is a 4. Just a V is a 5. A V followed by a 1 is a 6. V followed by 2 ones is a 7. Are we good with Roman numerals? We don't need more than 7. Can you say why? Because how many maximum do they gain and lose? Actually 4. Is that right? No more than that. But sometimes you see 6. That may confuse you. So no more than 7. Is that right? Because they are all trying to get to 8. Yes? 8 outermost valence electrons. Okay. So those are the Roman numerals. So I have to include such a Roman numeral after the name of the metal. Are you with me? Because it is a transition metal. Now, find out the total negative charge of all the ions it's bonded to. How many oxygens is iron bonded to in this compound? 1 oxygen. And what is the charge? Nancy is reading it out. What is the charge on oxygen, Nancy? It is -2. Now, all of that negative has to be cancelled. What can cancel a -2? Can somebody help me? A +2. So the metal has to be a +2. All right? Now, it's cancelled, right? So what is the charge on iron? It is Roman number 2. So this compound is named iron 2 oxide. Do you understand? Now, so I think in Tyler Dwight's video, he will say, okay, there is a -2 and it needs to balance. So iron has to be a +2. Is that right? Is that how he explains it? All right. Now, let's look at the next compound. This is also iron. It needs a Roman numeral and the ending is an oxide. Are you with me? Now, how many oxygen atoms is this compound attached to? How many oxygen atoms are there? 3. Now, so if you look at the negative charge, there are 3 oxygens times -2. What do you think that will become? -6. So the total charge on oxygen is a -6. Now what balances the negative charge? +6. All right? So that is a +6. Now how many iron atoms are there? 2. So you need to divide the +6 by 2. So what is the charge on a single iron atom? It is a 3. So what is the charge that you will write here? You will write 3. I think the way he does it in colored with video is that he does -2, -2, -2. Is that right? So you get a total of -6. And you know that there are 2 ion atoms. Is that right? You know there is an Fe and there is Fe. So how will you divvy up this -6 between 2 ions such that it cancels? You have to make each +3. Does it make sense? Yes or no? Does it make sense? So therefore this is iron 3 oxide. Are we understanding? So the naming becomes a little more difficult when you have D block or transition metals in them. Are we good? Do we understand this? Okay. So nickel is a transition metal. Yes or no? Ms. Meyer is here to teach something?
I'm going to go ahead, as you're working on this one, I'll write it out.
Okay. All right. So who would like to try and talk to me as I'm trying to do the next example? Somebody needs to help me. I need a helper. Who is willing to help me? Who is willing to help me? Without help, I'm not willing to do the problem. I need help. How about Kareem? You're going to help me. Okay? So what is the name of the metal, Kareem, here? Ni. It's Ni3 in this line.
Oh, and then 3. I couldn't see.
Yeah, Ni3. Nickel. So the name of the metal is nickel. Is nickel in the D block? Kareem? Is nickel a D block metal? Yeah, so it needs a Roman numeral. Are you with me? So I'm going to put Roman numerals like that. I don't know what it will be though. Kareem, can you first tell me what will P become? Phosphide. So P will become phosphide.
Ms.Geeta, let me interrupt for just a
Sure, sure.
Nobody in this room can do this unless you are looking at what Ms.Geeta is doing. Everybody should be looking up here. You cannot name unless you are putting the names down. Once she gets it done, it's not going to make any sense to you unless you're watching as she does it. The same thing with what I'm doing here.
All right? Are we good? Are we good with that? So we have nickel and phosphide. I'm going to erase all this for a moment so that I can work with the student. All right? Now, how many phosphorus atoms are there? Kareem? 2. So on my anion side, I have 2 phosphorus. And whenever I'm trying to find the charge of the metal ion, I'll always start at the anion side. Okay? Now, I have 2 phosphorus atoms. What is the charge on one phosphorus atom? Kareem? -3. So 2 times -3 becomes what? -6. Now I need to balance this on the cation side. Are you with me? What will negate a -6? A +6. Is that right? Now tell me, how many nickel atoms do I have? 3. If I have 3 nickel atoms, which together have a charge of +6, what is the charge on one nickel atom? 2 plus 2. Or in other words, did I divide 6 by 3 and get that +2? Does that make sense? Are you understanding? So what is the Roman numeral that I should be writing after nickel? It should be nickel 2 phosphide. Do you understand this? All right? The 2, I understand that that's a Roman numeral 2. If you write it like this, that's all the more better. Okay? Now, do I have a student who volunteers to help me with the next problem? I need a student volunteer. Yes, Gretchen. What is the name of the metal? copper. I know that I need a Roman numeral. What is the name of the non-metal? Chloride. Now, how many on the anion side, how many chloride ions do I have? 1. What is the charge on one chloride ion off of the periodic table? -1. So 1 times -1 will be -1. So this should be balanced on the positive side by the cation, right? So what will cancel it out? +1. Now how many copper atoms do I have? 1. So what will be the charge on one copper atom? 1. So what will be my Roman numeral here? 1. Does that make sense? That's copper 1 chloride. I need a student to help me with the next one. Who volunteers to help me with the next one? I need a student volunteer. Somebody volunteer. Yes, Justin. What is the name of the metal? Cobalt. What is the name of the non-metal? Phosphide. Now, always start at the anion side. Is that right? How many phosphorus atoms do I have? 1. What is the charge on one phosphorus atom? -3. So 1 times -3 is going to be -3. What will cancel the -3, Justin? +3. Now, how many cations do I have? 1. So what is the charge on one cation? 3. So what is the Roman numeral that I need to include here? It's going to be 3. Are we good? Can I get a student to volunteer the next example? Yes, Sto. What is the name of the metal?
Tin.
Tin. Very good. And what is the name of the non-metal?
Oxide.
Oxide. Now, how many oxygens do I have?
1.
1. What is the charge on one oxygen atom?
-2.
-2. 1 times -2 is going to be -2. What balances the -2? Or cancels the -2?
Oh, 2.
A +2. Is that right? And how many tin atoms do I have?
1.
1. So what is the charge on one tin atom?
Oh,
2 divided by 1 is going to be 2, right? So it's going to be 2 tin 2 oxide. Are we good? Can I get a student volunteer to help me with the next example? Who's going to help me with the next example? Yes, Daniel. What is the name of the metal?
Chromium.
Chromium. And what is the name of the non-metal?
Oxide.
Oxide. Now, how many oxygen atoms do I have?
3.
3. What is the charge on each oxygen atom? Huh? On one oxygen atom. 1. -2. So what is the total here? -6. What balances the -6? +6. How many chromium atoms do I have? 1. So what is the charge on that one chromium atom? 6. And how do I write 6? 1 followed by an I. Do we understand how to name metals that are in the D block? Can I see students do this half on their own? Can you do it